Okay, so this video is just meant to go through basic geometry and SOHCAHTOA for our right triangles. So there's this relationship, these trig relationships for right triangles, that if you know two of the pieces of information of a triangle, you could find the rest of them using either Pythagorean theorem or using the relationships of SOHCAHTOA. Okay, so this is the basic relationship, and you could actually look at the inverse relationships to figure out the angles. We're going to apply these principles to just two examples. Okay, so the first example we're going to look at is this one that says a sailor steers a boat 25 degrees north of east and travels 6 miles. Okay, so just this initial like north of east, what that means, like we know our traditional kind of compass settings, right? North, east, south, west, etc. So when it's saying 25 degrees north of east, it's like saying going east, here's east, and we're going to go 25 degrees north of it. Right. So the actual direction of this boat is this. He's going 6 miles in that direction. Okay, and displacement is a vector quantity. So I've got this 6 miles here, and it's 25 degrees north of east in terms of like a coordinate system. And so the question is asking how far north and how far east is it going. And so we can kind of think of like this part of the triangle as being the how far east, and this part of the triangle as being how far north. Okay, so in terms of using my SOHCAHTOA relationship, if I'm trying to figure out the east portion of this journey, east right here, east is adjacent to that angle. So I'm looking for the adjacent side. I've got the hypotenuse and I've got the angle. So the trig function that has adjacent and the hypotenuse is cosine. Remember, cosine of an angle is equal to adjacent over the hypotenuse. So that means that cosine of 25 is going to equal to this east side that I'm looking for, my unknown, over the hypotenuse value of 6. Now remember, when you are doing your trig functions in this class, you need to be in degree mode in your calculator. So make sure that the setting in your calculator is in degree mode. And you would just, rearrange this. The east side is going to equal to 6 times this value of cosine of 25. I'd stop the video, check on your own, or do the problem on your own and check, and you should get an answer of 5.44 miles. So very similar process for the north. Okay, so if we're thinking about the north portion of this journey, that is this upward portion, which is opposite the angle. And so the trig function that is associated with the opposite side is sine. Again, I know that you can do this using Pythagorean theorem at this point. I think a lot of you are well versed in your Pythagorean theorem skills, but maybe not so well versed in your SOHCAHTOA skills. So I would encourage you to continue using SOHCAHTOA to find these, just because it's good practice. So again, your sine relationship, sine of theta is equal to opposite over your hypotenuse, which in this case, it would be sine of 25 is going to equal to my opposite side, which is my north side, over my hypotenuse of 6. And you could pause the video, calculate what is 6 times the sine of 25, get an answer, and you should get that it is 2.536 miles. So I suppose you could just round that to 2.54 miles. So that's how you use the SOHCAHTOA relationship if you know the angle and one of the adjacent, or one of the sides of the triangle. Now, what happens if you know just the sides of the triangle and you're looking to figure out what the angle is? That's where you would use the inverse trig functions. So the inverse trig functions are here. We still have our relationships of sine being attached with opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. But now we're going to use the inverse trig function. So let's look at this second problem. It says on the edge of a river, you see a tree 15 meters directly across from you. So like here's your river. It's going to show you my amazing artistic skills. So here I am, the edge of the river, and I see a nice tree here. And this tree, according to the problem, is 15 meters away from me. And then it says I walk 50 meters downstream. So I'm like way over here now. This is not to scale. Here I am. I've now walked 50 meters in this direction. Well, that's a terrible 50. 50 meters in that direction. And it says, at what angle with respect to the river do you see the tree? So if you kind of think about your perspective, you are looking at the tree. Well, that is a terrible line. You're looking at the tree from this vantage point. And it wants to know, what is the angle with respect to the river do you see the tree? So it's actually wondering, like, what is this angle? And so we can kind of think of this in terms of geometry, in that I've got one side of my triangle is 15 meters. I've got another side of my triangle that is 50 meters. And I'm trying to figure out this unknown. So in this situation, I have the opposite side and the adjacent side. So remember that for tangent is equal to opposite over adjacent. That's that TOA. And if I do the inverse tangent function of this relationship of opposite divided by adjacent would give me the angle. So in this situation, I would take the ratio of 15 divided by 50, and then I would apply the inverse tangent function. You should try this out on your calculator. Make sure that you are in degree mode. You didn't have a wild radian night. And you should get an angle of 16.7 degrees. Now here's the kicker. 16.7 degrees with respect to the river. Okay, so this is indicating that my measurement line, like my angle, is, if here's my river, I'm measuring up from my river. So this is my 16.7 degrees up from my river is the vantage point I'm looking at. Okay, so this is key. When we're talking about angles, you kind of have to give a reference point. Okay, so hopefully this little bit of review of SOHCAHTOA and inverse trig functions has jolted your memory of geometry, and now you are going to be experts at using these functions.